Get started in just a minute here. So to those coming in, we have an A1425, and when I cherry picked this out of the queue, I was expecting an A1502, and when I opened it, I shuddered because this machine is very, very lousy to work on. Anyway, Nate's Tech Services. Hey Tim, working late, I see. Yes, I have been working until midnight, at least for the past good amount of time now. So we will get started. And Nate, we may actually work on your machine some, but that one might be a little bit boring for a stream tonight. We've already worked on it though, quite a bit, so just so you know. Okay. Lewis is having a meltdown stream. Oh, interesting. I probably picked a good time to stream. That's all right. Anyway, we'll go ahead and get started. This is an A1425 MacBook Pro from 2012. That does not turn on. And apparently it says that they replaced the charging port and it still doesn't turn on. Anyway, let me clean my mess right here. Get my keys out of the way. Stuff is falling, as usual. So, when they say they replaced the charging port, that makes me think it probably didn't have a green light in the charger. And as you can see, it doesn't have a green light in the charger. So, that can be caused by numerous things on this board. Now, this board is ancient. It's been a while since I've worked on one of these, and I just want to kind of skip around. I want to see what PP Bus G3 hot voltage is. I need my meter. I was doing something over here on a medical device, so I need to grab it. So PP Bus G3 hot voltage is going to tell me quite a bit. It's going to tell me if this is going to suck or if this is going to be something straightforward. So, this is such an old machine, like, if this needs an SMC, it's probably not going to get an SMC. Anyway. Oops, don't want to do that. PP bus voltage is 0.1. So, what I am thinking of when I have PP bus voltage of 0.1 is most likely PP3V42 is shorted or missing. So, I'm going to go ahead and get this board out of the enclosure and go from there. So, I already have one little bit of info here. That PP bus G3 hot is 1.5 volts. If we had an issue, let's say if the SMC was bad, I would expect to see 12.23 volts, not whatever it was, 1.5, whatever. So this does have hope. Now, this machine, I guess, you know what? I've given this machine a bad rap, but this isn't something that you really don't see these machines in too much. They're not that terrible. They're pretty... So I've probably worked on less than 10 of these in my entire time doing this. And that could be the case, is they're just not overly popular or that they are reliable. I don't know. They're not, I wouldn't say that these are overly bad, but they do kind of suck to take apart. And they suck to take apart compared to a 1466, but they're, in the grand scheme of things, they're not as bad to take apart as a lot of the new machines are. So, we're going to get this board out and then get started. I could already tell the board has been out on this before, because the screws have been removed. I could tell that by the paint being gone on it. So, if I remember correctly, This does share a lot of like design characteristics with the 2016 and newer machines, just with how they have it set up. It's kind of evil. This was like the evilest machine, and keep up on YouTube. So last time I saw this machine was like 2 years ago. Yeah, same here, Yusuf. Same here. It's been so long since I've worked on one of these things. Not one of my favorites. Okay, I think we're good to pull this out. Let's see, did I miss any screws? Yes, I did. One screw. Always hiding screws on these. 2 screws, actually. These don't really have like too many signature faults. There's this one trace I know I've seen that. Let's see, what is holding you in? That's right. I think there's a screw under the fan. Yep, that's right. They have an evil screw hiding under the fan. And there we go. Okay. So, no green light in the charger. PP bus voltage is 0.1. So that makes me think we have an issue on PP3V42. On this machine, if we have a short on PP bus, we're typically still going to get a green light. So I'm going to go ahead and check our PP3V42 voltage. Let's go ahead and open up a board view for an 820. Let's see, can I get this board without looking at this board? Do I remember? 820-3462. Let's see, was I right? 3462? Let's see here. Alright, just so you guys know, I'm not going to screen share here. Hopefully. I don't show anything I'm not supposed to in my documents folder. 3462, where are you? 3462. 3462. There, where are you? Somewhere right around here. $34.62 BRD open. Am I right? Am I right? I am right. That I remembered. Interesting. Perfect. Okay, so PP3V42, PP3V42 underscore G3H. It's going to show up in a few different places. Let's just go right at the edge right here. This guy looks pretty good. It's got a nice big resistor right here. This is actually the creation circuit, so we'll just go ahead and measure right there. Let me just check for a short real fast, and then we will carry on with actually diagnosing it and measuring voltage. So that is going to be right here, and of course it's hiding under the heatsink, so I could still get to that coil right there. So we're just going to measure for a short really quickly. Multimeters in continuity mode, and one lead on ground, one lead on the coil. And are we shorted? We are not shorted. Let me take an ohms measurement, and we are at, let's see here, come on. We are well in the kilo ohms, so we do not have a short to ground. So I'm going to go ahead and plug in my charger. I'm going to reposition my board a little bit, and I'm going to measure what voltage I'm getting there. And I am getting 0.02 volts, and it's kind of going up and down. So we could have a few different possibilities here. Our PP3V42 circuit may not be getting power. We may be getting power, but nothing is coming out. Or we have some other random circuit fault. We don't have a short to ground. according to our multimeter. Sometimes, rarely, you can get, I like to call them active shorts, where you don't measure a short with the multimeter, but you actually have a short to ground when power is running through it. Certain faults, particularly with silicon chips, can present that way. Certain chips here. And the regulator looks pristine. Like, there's no liquid damage here, and these guys really don't fail without liquid damage. I need to get this focused, by the way. Let me go to chat. 33 volts to the CPU for science. Interesting. I actually did that with a board that I need to upload. It was an older Core 2 Duo board. And I sent 30 volts to the CPU, and surprise, surprise, it stayed running. And if you actually, okay, this is interesting right there. I don't like the look of that component, but that looks like a coil. Sometimes you get a little oxidation on the top of it. It could look like that. But I'm just going to do a glance over it. So anyway, 30 volts to a Core 2 Duo CPU, and what do you know? It stayed running, it stayed booted. Okay, so we have some screwery here. That chip has been replaced. ISL something or other. That looks like a controller. That does not look like... Alright, so this has been worked on prior. Imagine that. So this cane did come from another repair shop, and it looks like they have worked on this prior. Interesting. Okay, so let's get down to business. So here's our PP3V42 circuit. We need to start checking our basics here. So let's make sure we have our charger voltage actually getting to our chip. So yeah, the SMC areas, I forget there's this one trace around the SMC where PP3V42 breaks off or something and it needs a wire. I remember that, but yeah, I don't think that's what's going on here. Could be wrong. Anyway, going to our board view, we're going to switch over to our display capture again. I'm going to do a search. We know this is our regulator, just some experience, but we could go through the schematic and search for it. I'm just going to pull it up right here. If we look at our system power architecture, we see that we have our adapter. We have a diode right here, D6905. Which is basically the enable. If it has 16 volts there, it basically enables itself. We have our regulator right here, and PP3V42G3 hot then goes to our SMC right here, or SMC reset chip, I should say, and that goes to a bunch of other stuff. Anyway, so we know that we are not getting this at the end of the circuit right here. Nothing right here. So we need to figure out, is our issue with something with here? Is it something before here? Is it this diode? Is it something before this right here? We don't know yet. So I'm going to go ahead and first off, let's look at our actual circuit right here, okay? So we have our input, our VIN, which is PPVin G3H 3V42 G3 hot, which can come either from the battery or the charger, depending on what power source it is. Depending on which power source the machine is on. Excuse me, I'm tired, but I have a lot of work to do. So PP bus G3 hot is going to be coming from the battery, or this one up here. Let's follow it. PP18V5 DCN connector R is, oh, imagine that, 18.5 from our DCN circuit. Okay. Anyway, I typically see when this happens, or when from experience, it's usually, come on, schematics program is being weird. Usually, it's either the diode or one of these resistors right here, R6920 or R6905. So I'm going to go ahead and measure voltage to see if we're even getting our charger voltage in. So I'm just going to go find D6905. I could just do this, and this is going to pull it up for me, and that is on this side of the board right over here. Who's that person peeking through the blinds behind you? I don't know, and I don't care. So let's go ahead and have a look here. And you notice that this has clearly been worked on. Someone has been here very clearly. And someone looks like they have tried to fix this problem before, but who knows what they were doing. It looks like they have failed at fixing this problem. So let's go ahead and check voltage right here. So here's our diode. We know this is a diode right here. Oh, let me make sure to switch to back to my microscope. Someone has clearly been here in this area doing stuff. This is totally unrelated stuff to what the problem probably is, but who knows what they were thinking. I don't know what goes through people's heads sometimes. But anyway, let's go ahead and check voltage. So we have our diode right here, and right here I have 0 volts. Imagine that. Okay, we have 0 volts there, 0 volts here, 0 volts here. Interesting. 0, 0, 0, 0. Okay, so we are not actually getting anything. So we are getting nothing from our charger. So here's our, let's see, which resistor is this? R6905 is PP bus, and R6920 is PP DC-in isolation. PP DC-in G3H isolation. So isol gate, it's a Mosfet right here, which is this guy right here. So we're not getting anything right here. Okay, so we're not going to replace the regulator. We're not going to do anything stupid like that. We need to see, and I'm always going to check on a separate grounding point if I'm confused if I'm getting voltage there or not. So I just checked on a separate grounding point. I'm not getting anything there. On our DC-in fuse, so this is our DC-in fuse right here, I am getting 3.2 volts. Now 3.2 volts does not sound like 18.5 volts. So why could our DC-in voltage be low? Well, probably a short. Sometimes we could have like Q7180 or something in the Inrush circuit be a little bit messed up, which can be the case. Anyway, I'm measuring 9 million ohms here, and there's nothing here. The 9 million ohms is not as short to ground. So my guess is we have something wrong in either our DC-in isolation circuit or our Inrush protection circuit. So Q7180, let's see, does this board have a Q7180 or Q7080? Let's look at our battery charge controller circuit. So we know now that our issue is not actually an issue with the PP3V42 circuit, it's simply an issue with power supply to the whole system. Something is up in our DC-in circuit and it is not letting voltage in through the machine. So we're going to figure that out. 3 volts is odd. That kind of tells me voltage is going somewhere that it shouldn't be. It's leaking. We shouldn't have 3 volts there. So let's look at our ISL 6259 circuit. And the reason why we're going to jump to this, if you're confused, how did we get there? How did we get there so far? Or how did we get here so fast is, well, I need to look at the Inrush circuit. And the chip that controls this is the ISL 6259. So if we look at this, we see that we have an Inrush limiter up here from adapter PPDCN S5 charger. Now we're getting nothing there. So Q7080. Q7080 can cause this. And one thing that sometimes you will see when this MOSFET dies right here is you can have an aftermarket charger that'll work totally fine, but a OEM charger that won't work at all. Now I don't have an aftermarket charger because I don't condone the use of aftermarket chargers. So I don't own one. But Q7080 is right over here, and we're going to take a look. So here is Q7180. Now, theoretically, what I could try to kind of confirm if my theory is correct, I mean, I guess could have a bad DCM board, but this looks like it's new. But new doesn't mean good. A little corroded, but nothing terrible. So one thing I could do to kind of see if my theory is right is actually cut the wire from the rest of the machine. So if I remove this fuse right here, which is unnecessary, but we could just do it as a test right here. If I just cut this fuse from the system, we should theoretically get 16 volts there. Let's go ahead and try it and see if that theory is correct. Because we could have something totally else wrong, or I could just go ahead and replace Q7080. We'll see. I want to do this for the learning aspect of this for you guys. No Tim videos lately because I have been a combination of very stressed and fairly busy. So, combination of stressed and busy leads to no videos. I have about 5 to 10 videos I need to edit. Now, I am using a really low temperature here. I'm using only 259 degrees Celsius because I don't want to melt our connector right there. So I'm using a pretty low temperature to take this guy off. It will take longer, but it'll save me from having to replace a connector that gets melted. Almost there. Come on. There's that. I'm just going to set him aside. We're going to let it cool down, and I am going to measure voltage here again. And if my theory of Q7180 is right, we should get 16 volts here on this side right here. So let's let this cool down for another few seconds or so. Let me check chat real quick. Yeah, Caleb has some form of the plague. I don't know, but I don't want to get it, so he is not here. And that's why I work until late at night. Connector is just fine. A little toasty, but it's fine. Anyway, what voltage do I get here? Okay, interesting. So I still get 3 volts here. So if I'm still getting 3 volts here, our issue is probably not on the system side, which is quite strange. Now, when we think about this, what possibility could it be? Is it a DCM board? I don't know. But let's go ahead and check. So let's see. Let's see here. What do we have here? This is a different DCM board for 1398s. Okay, interesting. So it's probably not the DCM board. Everything here looks, I mean, wouldn't say okay, but it doesn't look like it's going to cause an issue. I don't think it's the DCM board. It's never the DCM board. Let's look at possible causes for this. Let's go back to the schematic. And let's use our brain a little bit. Now, my brain is not in a very functional state as we speak because I'm pretty tired, as I've said. But we're still going to try and solve this. So, we don't have many possibilities here when we look at the schematic here. So we have come on, here we go. So we cut this off from the system. I mean, theoretically, we still could have an issue on the other side, but it's probably not. We only have one capacitor that's a no stuff, so this really doesn't make sense, does it? But anyway, we will carry on. So we have 3 volts there. I want to see what happens, what amperage draw. Now, I'm kind of just thinking out of the box here. I want to see what amperage draw I get if I just inject voltage onto there. If I have 16 volts, does the board start up? What does the board do if I just jump voltage to it? So let's go ahead and try that just for the heck of it and see what happens. So I'm going to get my power supply and I'm going to send 16 volts here and I'm going to see what happens. I'm going to see if I get any fan spin, any behavior, any signs of life from the board. And that's just kind of a, just a little trial here. .5 volts, 1 lead on ground, and 1 lead, well, the positive lead, you don't want to put positive on ground, but anyway, I have 0.13 amps, which is not enough for any kind of function of any kind. So that still kind of makes me think that something is up. So at this point in time, I kind of feel like Q7180 is bad. There's something really weird going on here. It's kind of not what I was expecting. But I'm going to go ahead and just replace a couple things. I don't really recommend you guys do this without properly diagnosing. But again, I'm tired and I want to get this board fixed. So Q7180 is going to go. The ISL6259 is going to go, and who knows whatever else here. Because this board is full of flux, and I don't like working on boards full of flux. There's more flux here. Lovely. Let's go ahead and put this fuse back on. You know what? I really wonder. Let's get this guy back on, and then I'll test my theory. If I can inject voltage at a constant rate, I could kind of figure out where it's stopping. Our charger probably won't like that because the charger needs communication adapter sense for it to work, but a DC power supply does not. So if I inject voltage here, I might be able to pinpoint where our problem is a little bit more accurate than just replacing stuff. So I am going to try that. So let's get our DC power supply, same voltage. This time I'm going to solder a wire right here. Let me put my fuse on. Briz, I've already filled Caleb's position, so if Caleb doesn't get back here by Tuesday, he's going to be replaced anyway, so yeah, sorry about that. Caleb has already been preliminarily replaced because of his absence, extended absence. Wish I knew where my flux went. That's weird. I just grabbed another tube. So many of you guys know there's been some changes to the Amtech Flux. I'm currently working with that. Well, I'm trying to get a video up with them, with someone from Amtech, as like a collab type deal. That's something I've been working on. I don't know if it'll happen or not, but I would love to make it happen. So that would be interesting. If we could make that happen. Caleb is appreciated here. It's been a whole week and I haven't replaced him yet. That's the limit, 1 week. When you're gone for more than 1 week, you go bye-bye. No, just kidding. Caleb's a good employee. We won't replace him for 2 weeks. We'll give him another week, and if he's still not back, then yeah, chopping block. Okay, so we have the same amount of amp draw. I want to go ahead and just check a couple of voltages here. I want to check what PP bus G3 hot voltage is. I want to check 3V42. I already know 3V42 is not going to be there. But what is PP bus? Let's see. Are you PP bus? Yes. Okay. So if I inject voltage there, I now have 12.56 volts. Now, you remember what I kind of said about the whole aftermarket charger type deal? Now, our board is still not going to be turning on because the charger is not going to be identifying itself. PM bat low L is not going to be asserted by the PCH and the SMC, so it's not going to work. But I now, with voltage injected, I now am getting 12.56 volts, which means PP3V42 is present and our board is basically turning on. So this is essentially what an aftermarket charger does, is it doesn't care about adapter sense, doesn't care about any of that stuff. It just rams voltage in, which is why we don't like them, because that is not a good thing to do in a lot of cases. Anyway, PP bus G3 hot, as you can see there, is now present and stable at 12.56 volts. So in this case, I am going to go ahead and replace Q7080 because I'm fairly confident that is going to be the issue. Anyway, let's go ahead and do that, and let's see if I'm right. So let's get this power supply off. I'll have to hunt for one of those on a donor board. Clean this up. I don't like using this other tube of flux. It feels alien. I want my tube of flux. Where's my tube of flux? I cleaned my desk today. This is why you never clean your desk. Because your tube of flux goes away permanently. They explained it, Q's Tech. Anyway, this could just stay bridged. I just want it to look a little cleaner. Yeah, that's fine. So here's Q7080 here. We're taking note of the orientation. The dot is in the top left corner. We're going to get a little flux down here. We only need a little bit. This will get UC'd though because it has been worked on and there's flux, and I don't like leaving flux on stuff. Now let's hunt for Q7180. Ah, first board I pulled out had it. Awesome. Love when that happens. Which is rare, but it's, I mean. That is soldered. I'm going to go ahead and plug back in my DCM board. I'm going to let the board cool down for a little bit. And then we're going to test it and see if we get glorious fan spin. Rainwater is not toxic. Yes, it can pick up toxic and stuff in the ground, but it's not inherently toxic itself. And based on the appearance of this chip, we can see that I was probably right on what the problem was. Look at that. Burned. Imagine that. But it did its job. Hopefully our ISL 6259 is not dead. I don't think it will be. Anyway, we had no light on the charger. We had no fan spin. It was totally dead. And what are we going to get now? Board's a little hot. I don't need a heatsink. This is a ULV CPU. And yeah, it's going to be just fine. And what do I get now? Do I get a green light? Do I get a green light? No green light. Interesting. So, yeah, same symptoms. Anyway, I want to go ahead and check voltage again. But most likely, our ISL 6259 is also dead. PP bus is the same. 3V42 is also the same. Okay. So, how this Inrush limiter is going to blow is if you use an aftermarket charger. Imagine that. It did its job. But I'm going to guess our ISL 6259 is probably also dead. I want to check my current sensing resistors. Yeah, we may have another blown resistor in the Inrush circuit itself. It's hard to say at this point. So this was probably an Inrush spike, which sucks, but is what it is. Carrying on. Let's check our current sensing resistors real fast and see if those are out of spec. I think they will be fine though, but I want to double check. Three ohms, 20 ohms, no issues there. And since people are in the chat right now, I should probably mention this just in case anyone wants to go. We have like 1 or 2 slots still open for the May MacBook class. If you're interested in coming to the MacBook class next month, May 13th through 22nd, I think it is, in Honey Eye Falls, New York, feel free to visit iPadRehab.com and sign up. I will be there teaching, and it'll be a great experience if anyone does want to take their skills to the next level. ISL 6259. Does this board have one? Can I just steal it? Yes. Perfect. Okay, I want to double check. Let's see. R7080 is pretty common too to fail. Let's look at R7080. Make sure R7080 is okay. That's going to be a 100 kilo ohm resistor. That is for the voltage divider. And our 7080 is right here. 100K. Okay. Same symptoms, which is really, really unusual. Yeah, this is why it really sucks when people replace a bunch of stuff on a board. This resistor right there looks very off. I did notice that, but I kind of brushed it off. That resistor there does not look well at all. That looks damaged. So, can I join? If you want to come, Yusuf. I don't know if you'll learn anything there because we're going to be teaching stuff that you already know. But yeah, if you want to come, feel free. Aha. All right. 3 volts. 3 volts. 0 volts. This is why repair attempts suck, because you'll have one little something like this, some little tiny finding that you will get trolled on because someone was an idiot. This guy, is this important? All right, one side is ground, so this may not be that important. R6912. That does not look very important to me. Yeah, that just goes right to ground. Yeah, note on the schematic, input impedance of 68K meets Sparkitecture. Imagine that. Sparkitecture requirements for both NPM4 and NPM5. Okay, this is actually pretty important. This is for the U6910, Q6910. So yeah, that one, we're gonna go ahead and replace that guy because that can be very important, and it is obviously broken. It's not blown or anything, but look at this, it's broken. It's physically broken. Where are you? Yeah, that's gone. That's no good. Yeah, if I touch one side of this resistor, it's probably just gonna fall off. Yeah. We'll use our hot air to remove it. I'm gonna switch to a smaller nozzle. Christian P is here. Is that Christian Para or someone else? I know several, well, I don't know several Christian P's. I know one Christian P, but I don't know if Christian P in chat is the same Christian P. Alright, let's rule this guy out. Let me find a 68K resistor because that is important. That is you. Nice to have you in chat, Christian. Alright, let's open a board view for 165. Let's find a 68K resistor, which is probably going to be lurking in the same circuit. Yep, same circuit, 68K ohms. We're going to pluck him. A little more flux here. I like when it's dry. This does make sense if that was the issue, but we're gonna see. Okay. Is that it? What do you frickin' know? Green light. Are you gonna have a fan spin? You gonna have a fan spin? Fan spin, please? Please, fan spin? That is a spinning fan. Imagine that. So, That's not good. That's probably wants a heatsink. It probably wants a heatsink. This is why repair attempts suck, because you get stuff like this and you get trolled. Anyway, let's make sure this stays running, and it does. No, it doesn't. That's interesting. Okay, so volume 2. What else is wrong with this? We don't know because it was screwed with. Imagine that. So when you have that weird fan spin type thing where the fan spins then stops, that can be pretty much anything. And yeah, that's can be anything. PP bus is 12.57. I'm getting a fan spin, so that means we're getting at least somewhere. I've seen that be the ISL 6259, which I just replaced, so I don't think it's the ISL 6259. That's a really, really broad issue type, where it turns on, it sees a problem somewhere, and then shuts right off. Let's see, do I get a pulse on VCore? Alright, now our fan is staying running after I push the heatsink onto the CPU more. Can this be this sensitive to a thermal trip? Let's see. Maybe it is. Maybe it just has flux all over it, or maybe the board was still too hot to turn on. I don't know. That could have been. It could have been tripping a thermal sensor. Not the CPU thermal sensor, but a thermal sensor on a different part of the board, which because we just reworked it and said nope, SMC shut it off. And just so we show a little teaser here, which it's getting close, but it is not ready yet. Hang on here. Let me grab it. It's not in my reach. But I will have a little teaser, which is that's all I'm showing. Soon. Anyway, we're going to put this heatsink on. We're going to put it in the enclosure. We're going to see if it boots up. And then I could, if this does boot up, I unfortunately have to ultrasonic this myself because, you know, someone in my live chat decided to not come to work anymore. So we have our CPU heatsink on. I just have 2 screws in it. That's all we really need for right now. It's going to come off anyway. I'm just going to plug it in again and see if the fan stays spinning. And it appears it does. I think it was just the board was too hot and the thermal protection system did its job. It tripped a sensor and shut down because we just reworked an area of the board. And yeah. Anyway, it stays spinning. So we're good. We're good. We're good. We're good. Let me grab the enclosure here. Let's go back here. I hate this machine so much. I swear, I shuddered when I opened this. I grabbed it out of the slot and was like, oh, cool, a 1502. No green light on the charger? It's an easy D6905 issue. Or one wire circuit issue. And then I opened it and it was like, ugh. No. Chills. Terrible. Excellent, Caleb. I'll see you in an hour. I guess one thing is, since Caleb is sick, I don't have to help him change his intake manifold on a 4.6 Ford 4.6 liter engine, which is not a very fun job to do. If anyone's ever done it, it's not very fun. Anyway, we already have a backlight. Now, imagine that. The SSD is not actually connected to our board. It's connected to our trackpad, which is unplugged. So we will get a flashing question mark here. If your SSD in this dies, sorry. Like, yeah, good luck finding one that works. But this should get a flashing question mark here. At least it's not a 1534. Oh, I have multiple 1534s that I need to change the CPUs on. So, yeah, that sucks. But we're going to avoid that problem for now, all right? We're going to pretend that the 1534s don't exist for now, okay? Thank you. Well, we have backlight. Give me question mark. Come on. Yeah, I know you're a dual-core 15-watt i5. I wouldn't want to be alive and displaying an image either. Come on. I know you have backlight. You're in there. Did you guys just see that? What just happened? Anyway, let's put this back in properly so it doesn't fall out. And I'm going to plug in our trackpad. So this is something that I do need to address, because I see it being talked about a lot, and I see people saying, "Oh, I have no image. I have no image." If you have backlight, you have an image. The CPU is talking to your screen. You don't have a no image issue. I mean, you can have a no image issue, or you have. MacBooks don't really have image issues like iPhones have image issues. We don't see like blown filters or anything like that. You could have it's common. The most common thing when you have a black screen, and no image is usually the display's T-con board is bad, or like just a bad display. Usually the T-con board, especially on newer machines, but. Caleb is like 29, 28 something. If he has COVID, he's not going to have O2 saturation issues. And just so everyone knows in chat, I was not around Caleb when he was sick. Or before he was sick. So, I am not infected. I have not infected anyone, and I have not been infected. Webcam cable screwed up as well. Okay, let's try again. Now there's at least something holding in the board a little bit better. We have backlight. We just lost backlight. We have backlight again, and that is an Apple logo. You didn't want to give us a question mark, stubborn piece of junk. This machine should not exist. It shouldn't exist. It's a MacBook Air with a Retina display. Apple logo. There you go. It boots up and it works. What is this? I just noticed this. Nah, I can't show you. There's this like lock type assembly on the display. That is bad, okay? And the reason why you should not stick stuff like this to your laptop is when this falls, all that pressure is going to be directed at a single point in the display, and you're going to shatter your display. Now, you may think, oh, it's just a screen, it's going to be cheap. No, it is not. A screen repair on a MacBook is one of the most expensive repairs that you could possibly have. Screens for A1502s, which are older machines now, are typically more than the cost of a used machine. 1502 screens, last time I had an inquiry for one, were around $600 a screen for a new screen. Don't break your screen. Don't put stuff like this on your display. Don't put webcam covers, little webcam shutters on the top of your display here, because it will break. It will break your screen. If you're that paranoid, use a piece of tape. Anyway, this is done. I gotta get it in the ultrasonic cleaner. Ultrasonic cleaner is hot. And then we're gonna grab another machine. Where's my phone at? Oh, right here. That's not fair. Where's my T5? Grab a new one, whatever. Yeah, this paste spreads really well compared to a lot of other pastes. So I'm really excited to when it is going to be released, but I am not going to release something prematurely either. So carbon black was one of those things. It was worked on for so long. I mean, carbon black was worked on extensively. And we will be releasing a revision of carbon black very shortly, which is going to improve on the performance and longevity of the first version of it. Now, the first version is by no means inadequate by any means. It is a very, very good product. But we have upgraded our manufacturing equipment to be able to manufacture the thinner regular type thermal pastes, and doing so has resulted in the ability to improve the carbon black formula even more. How about a speed run any percent on the next MacBook? I'm not sure what you mean by that. What do you mean by a percent of the next MacBook? I don't know. I'm too tired. My brain doesn't want to work or understand that right now. Okay, let me clean this up. We have two fans here. I'm just going to put this up here. Fans, DC inboard, heatsink screws, heatsink. This Q7080 was bad too. The way it was burned, it may not have been showing symptoms of being bad, but it would have very shortly. Let's clean up, and I'm going to go cherry pick something easy from the front. Got to clean this up. Fix it fast. I could try and fix it fast, but I don't know if I'm capable of fixing anything fast right now because I'm pretty tired. If I haven't said that already. Alright, should I try and fix this fast? Maybe. Okay, we'll try and fix it fast. Let's see if I have a 1466. I want a 1466. Finding a 1466 here is not going to be possible. 1990. Power issue. Overheating, not powering on. A1398. What are you? Overheating and not powering on. Hopefully it's a 2012. In that case, it's U8900. It's not overheating, it's just getting warm. And they assume it's overheating because it's not turning on. It's not turning on because the GPU does not have power going to it because the solder joints on U8900 are cracked. Which is very common for this model. Anyway, let's open this up and let's try and fix it. If it is a late 2013 or 2015, and it is not turning on but getting hot, it is probably a dead CPU. In which case, PP bus is flowing freely into our CPU through one of the CPU Mosfets, and that would mean the CPU is dead, and I am not going to replace the CPU on a 1398 because I don't replace CPUs not for non-data recovery purposes. You should have taken my A14. Yes, I would love to have that A1466 here. What do you know? It is a 2012 A1398. And I believe I was right about what the problem is going to be. Let me move this here. Okay, so one of the most common things on 1398s when you have an issue like this is they will work after being shipped across the country because you have cracked solder joints, and bouncing around in the back of a truck will cause this. Will cause it to work again. Fans are spinning, so our... Yeah, see, look at this. Imagine that. Not powering on. Well, it is powering on. Okay? This is the importance of knowing histories of devices. You bring it into a repair shop, and people are like, or the technicians are, oh, this is working, it must be fine. No, it is not. It has cracked solder joints on a particular chip. Anyway, let's get this off. And contrary to popular belief, this is not the battery. Don't replace the battery for this issue. Wes will, who was it? Was it Wes that said? Yeah, Wes says speed run this MacBook. Perfect, we will do so. You got lucky, I found something easy. I miss these days. I miss fixing these. I miss the days of removable storage, no ARM64 cores inside the NAND SSD chips. Transient vibration repair. That's right. Very effective. Sometimes you'll get people that'll bring these in as walk-ins, and they give it to you, and oh, it works. And they're like, oh, it works now, I'll take it back home. And you tell them it's probably not going to work very shortly, and they're like, no, it's fixed. It's fine. They get it back home, it doesn't work. And then you get to repair their board. Now, there is one trap here that a lot of people don't get, is taking this little plastic cover, this little plastic thing for the I/O board off. It's really easy to nick one of these resistors off, and you don't really notice it because it's for HDMI, and let's be honest, who checks HDMI on every single repair? I need a good T5. Where's my good T5? That's sad. Here it is. Same type. Okay. I'm not going to lie. The T5s that come with batteries, the little green handle ones, are not bad. I don't know why, but I like them. And I use them more than any other T5 that I have. The little green handle T5s that come with the batteries, I like for some reason. Maybe I'm just weird or incompetent. I don't know. Why don't you want to? Did I miss something? No, I did not. There we go. Okay, and let's see if I'm right. Let's see if U8900 is the issue here. Let me go switch this board real quick in the ultrasonic because I don't want it sitting in there. Gotta flip it over. Let me move this MacBook out of the way so it doesn't get wet. Not be good. Alright, let's go. And usually you will have severe solder joint cracking on this side of the chip. And if we look at it like this, we can clearly see there are cracked solder joints. Look at those. Those are not how solder joints are supposed to look. Okay, see how they're all like rough? Shouldn't look like that. They should look like this. And even there's some cracking there. Okay, it should look like this chip right here. It should look clean and smooth. It should not look like that looks like. Okay, so we're going to go ahead and resolder this guy. Flux, iron, heat. I had one of these that I did not bridge it, but I killed the chip with heat, or the chip just happened to die at the same time, and it ended up killing the GPU. It wasn't bridged or anything, but the GPU ended up, the Mosfet shorted and the GPU died. My guess is just that chip was on its way out and the heat kind of just threw it over the edge. Rare, but it can happen. Now this issue can reoccur. We've had a couple that have come back after about a year that the same thing did occur, and we have a trick now to prevent that, and I'm going to share that trick with you. Apple used a little piece of rubber which really did not work well. That little piece of rubber was just meant to mash it down to the board, apply pressure on it, and that did not work well. The issue is occurring not because of flexation of the board, but due to expansion and contraction of this area of the board. Now, this GT650M graphics chip right here can run pretty hot. They will hit around 90, 95 degrees and then throttle back, and this just happens to be in the part of the board that gets hot, and the heating and cooling will cause this guy to develop cracked solder joints on it. So, if you place the thermal pad over the chip, that thermal pad will absorb that heat and it will slow the expansion and contractions down, so it will not experience the same amount of stress. Now the thermal pad covering the chip will kind of act as an insulator a little bit, but it's not a problem because the chip will remain within its specifications, and that thermal pad will retain some of that heat and it will disperse that heat over a larger area rather than just the chip, and it will prevent that issue from reoccurring, or at least reduce the chances of this reoccurring. Static sound, that is because the ultrasonic cleaner is on. Ultrasonic cleaner produces a static sound. Ultrasonic cleaner shut off, and you should have no more static sound now. Clean this off. Almost clean. Switch to isopropanol from acetone to give the finishing touch here. Okay, I'm going to dust this board off, reapply the thermal paste, and then we're good to go. Let me grab a thermal pad. And yeah, so these are just, you don't have to worry about the watts per meters Kelvin of the thermal pad. Just get the cheapest you can get. Any little thermal pad will do. And you're just going to place the thermal pad right on top of the chip like that, like so. Not this one, it's this one. Alright, just like that. Give it a little push. That's all you need to do. And that's going to dissipate the heat around the chip, and it's going to slow those expansion and contractions of the chip and the surrounding area of the board, and should stop the U8900 chip from getting cracked solder joints again. Because it can reoccur. Battery's a little bit bloated, not a problem, only 2 cells. I mean, it is a problem, but it's not that bad right now. So let's go ahead and put this board back in. Reassemble it. I do have to reassemble it. I am going to reassemble it on stream. I'm sorry. I know it's boring. I'm going to reassemble the other one on stream too because I got to get these out. These boards can be a pain to align sometimes. Always make sure the Thunderbolt port aligns properly, because sometimes you'll get someone that comes back and says their Thunderbolt device doesn't fit, and it is kind of an easy board to misalign. So just be vigilant, double check your alignment, make sure that your screws are perfectly lined up, and you'll be just fine. Just make sure your screw holes on the board are exactly lined up and not at all off, because it does matter and you won't have an issue. That's primarily a 1398 thing. They just like to be really stubborn. This screwdriver sucks. Just make sure. It's pretty good. Almost done. Actually, got to reapply the paste. Forgot about that. Got to reapply the thermal paste. Now, I will not be using our internal paste, the one that is still in development, because I'm not going to put a product that is not yet ready on a customer's device. So we are going to apply a tried and tested product until ours is ready. If we're just doing stuff like, let's say, like that one board testing, it's fine to use, but I'm not going to release a product. I'm not going to use a product that is not yet ready. This one screw, I hate when they do that. Sometimes these screws are really difficult. If the heatsink has never been off of the machine in several years on these 2012 1398s, the screw can be incredibly difficult to get out without stripping. So I'm going to kind of put some force into it. Let me open the screen so I don't bust the screen. Will you fix a one wheel? I don't know what a one wheel is. What do you mean? I might know what a one wheel is on a time that I'm rested. Okay, that is just spinning. I need to get a different screwdriver for that. Let's see. Might have a T3. Should have a T5 here somewhere. Wasn't there a magnet here? Yes, right here. Some T5s are just a little bit bigger. That's what I like. I don't like using. I mean, I don't really assemble stuff anymore, so I shouldn't be talking. Nope. That screw is nonsense. Okay, so this is a good point to show you guys how to remove this when it happens to you. So what you're going to do is you're going to grip the base of it with a pair of wire cutters, right? Grip it tight, 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 and turn it, and it should come right out. And then you should be able to take it out with a regular screwdriver. So we'll replace that screw, but just grip the screw really tight, and this paste has suffered from the pump out effect, as I'm going to show you here. So we'll talk about the pump out. I'm going to have a dedicated video talking about the pump out effect. But when people say, oh, yeah, I'm not repairing a skateboard. No way. I'll repair an MRI machine stuff, but I'm not going to repair a skateboard. When people say thermal paste dried out, okay, thermal paste doesn't dry out. What happens is the silicone oil pumps out or separates from the filler, which is usually aluminum or aluminum oxide, aluminum zinc oxide, aluminum nitride, boron nitride, all kinds of stuff. Anyway, this is an example of thermal paste suffering the pump out effect. Notice the solids right here, which are thick. Okay, look at this. This is pretty much solid. Okay, looks like we have aluminum in here. It's kind of hard to see, but that's aluminum. Probably has a little zinc oxide in it too. But you have all these solids on the side here, right? Okay, there's going to be more under here too. And then under the die you have this stuff, which is like clear. Look at that, it's clear. It's like liquid, right? That is the silicone oil that the paste is suspended in. Now, aluminum has a thermal conductivity of around 2 notice the larger particle is aluminum here, about 5 to 10 micron. Silicone oil has a thermal conductivity of like 0.6 watts per meters Kelvin, and aluminum has a thermal conductivity of like 200 something. Anyway, the point is, that is not good. That is not what you want. You don't want just silicone oil on there. Now, this is something that happens with pretty much all silicone-based thermal pastes, or a lot of all thermal pastes. We're trying several different base fluids to kind of combat this. We have had some interesting results. Not really going to talk about it, about what we're using. But, you know, it is coming along. But that is what the pump out effect is. Thermal paste does not dry out. The silicone oil simply separates from it, flashes off, does whatever due to the pump out effect. Eliminate pump out and your thermal paste will last forever. The pump out effect, though, cannot be completely eliminated no matter what you do. It can be significantly reduced. Something like, oops, I just almost broke my microphone. My microphone snagged on my chair, which isn't good. This is an expensive microphone. I don't want to break it. Anyway, I'm too tired. I'm just rambling at this point. I sound like a crazy person. I sound totally like a crazy person right now. I think most people in this industry end up going crazy anyway, so there's that. Fresh thermal paste. Switch back to this camera. Fetch a replacement screw for that very stripped screw that we removed. And if you have a screw like that, don't put it back in. Please replace it like you should. We have a collection here. Now, if you're a repair tech, you will end up collecting hundreds of screws, extra screws that seemingly come out of nowhere. It's just something that happens. No one can explain it, but you end up with hundreds of screws. And you usually will have the right screw not far behind. So we're just going to look. And this looks like it might work. And indeed it did. No, it did not. Don't want to long screw it either. But I do want good heatsink mounting pressure too. Perfect. Okay. So we just now need to finish plugging everything in. Here's our bad screw. Let's throw that away. This guy right here is going to go right here. I hate doing reassembly or disassembly. Okay, now I'm going to take a short break after this is all assembled, and I am going to go get that board out of the ultrasonic cleaner, and I'm going to go cherry pick another MacBook for us to fix tonight. That's in. SSD is in. Let me check my chat. Quite a bit. What time is it over here? 10:37 p.m. I wouldn't airdrop anything to anybody like that. I would probably get annoyed if someone did it to me, so I wouldn't do it. But I'm easily annoyed, so. Here's the thing. You can't, in my opinion, if you advertise to everyone of a service they don't need, they're not going to care. They are going to come to you when they need a service. So, let's plug this in. It's better to have strong SEO and to be very visible when someone searches for you, rather than just blasting ads for no apparent reason. All right, this still boots up. This will need to charge, and this will need to go on testing. Let me put this bottom cover back on real fast. And then I'm going to go put this one on testing. Get that board that we had in the ultrasonic in the toaster oven to dry off. And cherry pick another one. Wait, this is the wrong screw for you. No, it's not. Yes, it is. You go here. Repair is good, says our wheel. I agree. Repair is good. Even though I'm terribly burnt out on repairing things, I still agree that repair is good. I was just reflecting the other day. It has been 6 years since I have been doing this. And it does not feel like 6 years. It feels like a blur after the second year. So from the time I got my store, late 2018, early 2019, wow. Yeah, it's a blur from that point. Do you use dishwashing soap for your ultrasonic cleaner collision? No, do not use dish soap. Use Branson EC. Do not use dish soap. Dish soap does not belong on a circuit board. Do not use dish soap. I repeat, do not use dish soap. Use Branson EC or a comparable ultrasonic flux cleaning solution. Not dish soap. Please don't use dish soap. I'm going to mute because I have to sneeze. So organizing the small mess I made over here. 1708, no Bluetooth. That will suck. We'll get to it. We'll get to it. Yes, Peter has a good point. Do not use isopropanol alcohol for your ultrasonic cleaner. If you use isopropanol as your ultrasonic cleaning solution, that is a great way to cause an explosion. Now, I know some explosions can be cool, but having an ultrasonic cleaner full of isopropanol explode in your shop probably will not be the type of cool explosion that you want to see. So don't do it. Be smart. Don't put a flammable liquid in a heated and vibrating machine. We're just going to dry that off, and I just lost my mic. There we go. Okay. Keep snagging my mic. I hate this long microphone cable because it constantly snags on stuff when I'm walking around. It'll grab on a chair or anything and just pulls, and it tries to pull it off my head, which is not fun. Almost ready. Just booting into my test disk. I'm going to start this on GPU stress testing, dry that for 1425 board, and then we'll cherry pick another one. Let's get this guy dried off real fast. So you can use an air compressor. I'm going to be a little bit lazy, and I'm going to use my hot air. We're going to do 200 Celsius at max air, and we're just going to heat from the back and just dry this off. And then we're going to put it in the oven. I don't like a lot of heat directly on the CPU, so I'll do it on the back side. And once it's mostly dry, the oven will take care of the rest of that work. And we're gonna go let this chill in the oven now for a little bit. We'll do about like 10 to 15 minutes. 150 degrees Fahrenheit. Let's go ahead, and this thing started in recovery, so we're gonna restart again. Boot back into our test disk, and while that's booting, I'm going to go grab another one from the front. And let's see here. What is this? A1707, A1990, A1707. A1707 with, come on, 20 volts, 0.1. That sounds like a PCH. Hopefully not the PCH. I don't want to change a PCH tonight, but if I have to change a PCH, I'll change a PCH. Are you baking pizza? No, I'm not. Anyway, A1708, 0.1 milliamps. Let me sign in my test disk real fast because this booted up. Super secure password of 1234 on the test disk. And then I need my suction cup. I don't feel like replacing a PCH on stream, because that means I have to clean the ME region. Hopefully it's not the PCH. Let's hope it's not the PCH. Could be a PP bus short. This has been worked on prior. Imagine that. Anyway. Let's see. Missing screws. Any signs of board rework? It doesn't look like it. Okay, plug it in. Multimeter. PCH is, okay, now we're getting 20 volts, 0.24. And it cycles. Lovely. PP bus is 13. It's cycling because this amp meter sucks. I think this amp meter just totally broke. Yeah, this amp meter just totally broke. Alright, we have 12.6 volts on PP bus. Should we fix this on stream? Let's see. Let's fix our amp. Let's take a little sidetrack. Let's fix our USB-C amp meter so we could continue working, because there's more around here, but I don't know where they are. And yeah, let's fix our USB-C amp meter. These things are such garbage. Yeah, this one is a whatever this says. It's not good. It's like plaster welded together, which sucks. Get it open though. There. It is open. Now let's have a look. Look at all those broken solder joints. Look at that. Interesting. Did not want that bridge. Come on, little stubborn bridge, get out of here. There, done. There's one side, and then we're going to do the other side now. Is that thing from China? Of course it's from China. Want a nice big blob on this end little piece. Yeah, right there. 'Cause that's where they like to break. That is exactly where they like to break. Okay, that's better. I think we're good now. Snap this back together. Gonna Captain tape it together. Wait, this goes on the other way. Actually, we don't even need to. Yeah, I guess we should. And now it should be good as new. And let's plug this back in and see what we get. I put this together backwards. And it still doesn't work. Imagine that. Alright, let me go hunt down another one. Let me steal one from Caleb's desk, but Caleb's desk doesn't have one. Here is one. Perfect. Okay, now while I'm over here, I'm going to start my GPU test. Okay. Got a new amp meter. Well, not a new one, but better than the one that we had. And we get 20 volts, 0.03, 0.04, 0.03, and so on. So when I think about something like this in a 1707, there's something amiss in the power-up sequence. What? I don't know yet. But there's something definitely amiss in the power sequence. So what I'm going to go ahead and do, and this has been worked on prior, check PP-bus. PP-bus is present. Now, I am very suspicious for a dead PCH. I just have that feeling that the PCH is going to be dead. So I'm going to check PP3v3 sus. I'm going to cheat a little bit, skip ahead, and check PP3v3 sus. Now, PP3v3 sus powers a lot of the PCH's functions, and PP3v3 sus will just show up at one of these JTAG connector headers right here, is 0.0 volts, as I kind of thought it would be. Are we shorted? We are shorted with less than an ohm to ground on PP3v3 sus. Now, I probably don't even have to take the board out to tell you this is a dead PCH, which we can replace, but I don't feel like replacing it tonight. So let's look and see. I mean, maybe it's a capacitor. Very unlikely to be a capacitor. Do I have any signs of damage? Looking for little, like, brown spots. I don't see anything. Okay, let's go ahead and get our thermal out. Actually, do I even want to use thermal? I kind of just want to inject voltage and feel the PCH because I'm tired and I don't want to inject voltage. Or I don't want to take the board out, I should say. So I'm just going to inject voltage right here on this little guy. I'm too tired to change PCH. Let's make sure I turn my voltage down from 16 volts. 16 volts right into 3v3 sus would be a very, very interesting sight that I'm sure you guys would love to see, and I would probably cry. So we're not going to do that. No 16 volts on sus. I had a friend that I was using their power supply one day on MacBook voltage, and then they plugged it into an iPhone. And yeah, the expected happened when you send 18 volts to an iPhone. Anyway, I guess I'm just going to show you that alcohol will boil on it. Yeah, 2.3 amps. Alright, that's hot. That's going to get hot quick. That MacBook has blown speakers, that 1398. I could hear it. Here's our PCH. 2.3. Wait, it's not getting hot. Does this have hope? The ground is getting hot. The PCH is not getting hot. This has hope. Let's pull this board. Let's pull this board. This is a cap. This is a cap. Might still be the PCH. How long have I been streaming? A long time. Yeah, Rob, it's an interesting sight. I gotta turn off the darn sound on this GPU stress test. It's gonna drive me nuts. Listen to what this sounds like. Oh, thanks. I don't want to hear that. I want to hear the fans running. Come on, I hate that the mouse always hides on Valley or Haven or Heaven, whatever it's called. Here, you know what? There. Easier. 230 volts into a board would be fun indeed. That board would never work again. .3v3 sus is shorted Yusuf, less than an ohm, so it could be something around the PCH. I injected voltage, the PCH didn't get hot initially, so I have hope that there's a cap on the other side of the PCH. It is shorted. Still could be the PCH, but, you know, I haven't used my thermal or anything, but we will. It's probably the PCH. I have hope that it's not. And this has Phillips screws in the display connector shield, which means someone else has screwed with this before. So who knows what we will find on the other side. What is this? There's a screw or screws. There's no screw supposed to go right where they put a screw. So there's supposed to be a hole on this shield for the bottom case screw. Okay, you don't jam a screw in there. Door is open behind you. I hope it's not open behind me, because that means I left it unlocked at almost midnight in the Antelope Valley, which is not a very settling thought. If this is just trash, I'll grab a new one. Bailey, by the way, how has things been? I haven't talked to you in a while. How's things down under? How's it going, Malls? Long time no see as well. Yeah, you probably won't be able to scare me like you did the first time. That was a long time ago. And I swear that when you did that, that was right around the time that some kind of weird stuff was happening in the shop. So, yeah, you got me that time. You'll never get me again. You'll never get me like that again. T8, where's T8? That's T9. T7, where's T8? Okay. Now, with my thermal imager, there's like a 50-50 chance that it will work when OBS is open, so I can't guarantee or I'll be able to show you guys, or that I'll even be able to see. So just want to do a little overview. Maybe I'll have a visual sign of a cap and be able to just flick it off and be done. So there's only like 1 or 2 caps on 3v3 sus. They're going to be in this area. And everything here looks decent. So, yeah, so where could this go? First off, where's a good point for me to inject voltage? It comes from the PMIC. We know it comes from the PMIC. It goes to several different components. And there's several different possibilities of what might be shorted. But a good point, I want a nice solid point to inject voltage to. And this guy is perfect. This is a voltage sensor. Gonna use my fatter wire. I'll be really sad if this ends up being the PCH. Well, we're pulling almost 5 amps now. Just feeling around, I don't feel anything. Something around the PCH. Okay. Need thermal. I don't want to, at 5 amps, I don't want to leave my finger there for too long because stuff can get really hot really fast. So we are going to switch and try and open up our thermal software and hope it opens. Because again, it is a 50-50 chance. It's more like a 20-80 chance. 20% it works. 80% it doesn't work. When we open this. And it does appear to work. Okay. So, we're going to have a dead PCH. What are we going to have? Yep, dead PCH. Okay, so I will change the PCH on this. Not tonight. Clear as day. That is a dead PCH. Bye-bye. Rest in peace. Little PCH. Dead. This will need a new PCH, and this will need the ME region cleared. If you don't clear the ME region after you replace PCH, you will get long post. Okay, this one is squared away. I have a 1990 to look at now. And I have no slots available up here. Perfect. Guess it's going to chill right here because I don't have any slots available. Let's grab this 1990. Water damage. Water damage. Damaged by water. Okay. What do you do, little 1990? Will you be easy? Will you be hard? $5 volt 0.24, 0.27, 20 volts 0.09, 0.37, trackpad click, half an amp, a full amp, that is like booting. Okay, I just got touch bar just lit up, and it looks like I have no backlight. Do I have no backlight or do I have no image? It's really hard to tell on these machines. It's almost impossible to tell if you have an image or backlight issue. So my trick is hold your flashlight right at the center of the screen and wait for the Apple logo. So this at least does turn on. I do get touch bar, but nothing on the screen, which can be many things. It's near impossible to see the displays on these, so anyway, we'll open it up and have a look. How is my data recovery doing over here? By the way, let me check on this. Hoping this is a backlight issue. I'll give you my blessing, shorted cap on backlight. That would be really nice. So this says it has liquid damage. It looks clean. It doesn't look like a machine that has liquid damage so far. But a shorted cap on backlight would be really, 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 really nice tonight. And again, it's been opened before because I could tell you there's a little wrong screws everywhere in this, so someone else has worked on this again. Oh, lovely. I love when the Touch ID doesn't have screws in it. Just this kind of just chilling out. Okay. Whatever. Okay. Let's check backlight output voltage, see if I even get anything. I'm not going to get anything. I could tell you from experience I'm not going to get anything. .89 volts. Interesting. So, disconnect power. Let me put this Touch ID back in here so don't bust the screen on this. I almost wonder if it was the screen was closed on the Touch ID sensor, and that's what broke the screen. I just don't know why people don't put screws back in stuff they work on. It bothers me. And I have 200 ohms on backlight, which is way too low. So I'm going to go ahead and unplug my screen, but 200 ohms seems fairly consistent with a shorted backlight capacitor. So that would be really nice, and thank you, Yusuf, for the blessing on that, because that would be really nice to have. I just need to find some screws for that Touch ID, because I can't just leave that dangling out there like that. Unplug my screen. Okay, so there is liquid on the screen, and that's not good. There's corrosion on the screen. Still have a short, so it's not that. I had a problem with the iMac A1418. I have changed with HDD with SSD, and I have yes, you have a thermal sensor issue. I don't work on iMacs. I haven't worked on iMacs in a really long time. Someone outside my store? Check my cameras. I hear talking out there. That is odd. Beats me. There's this one model iMac. It might help. A1418 is pretty broad. What year is your iMac? I should say that. What year and model? What year do you have? Because some of those have a sensor in the hard drive that needs to plug in. If it is a two-prong thermal sensor that plugs into the hard drive, what you can simply do is just twist those wires together, and it will think it's at 0 Celsius, and it will work. I think that's 2009's like that, but I haven't worked on iMacs in ages. That would be a question for Caleb E., who was in the chat earlier. He may still be in the chat, and that's a question for him, because I don't know. I used to know. I don't know anymore. That has been purged from my brain, because I don't work on iMacs anymore, and I haven't worked on iMacs in almost 2 years. I haven't touched an iMac in almost 2 years. Yeah, I think it's a 2009. If it has a if you had something, a little two-prong sensor that plugged into the hard drive that you had nowhere to plug it in with the SSD, what you need to do is cut the connector off of the hard drive side, and just twist those wires together so they touch. So make both wires touch. You could also put a little solder blob on the board side, but you need to get that connection so it touches, and then it'll read 0 Celsius and it'll stop that nonsense. There's wrong screws literally everywhere. And I put new thermal paste in CPU and new SSD, but oh yes, exactly what I just said. That is a thermal sensor issue. The fan is on fast because one of the thermal sensors is not reading properly, and it is probably a 2009 iMac. That two-prong sensor is not plugged into the hard drive because there's nowhere for it to plug in on the SSD, and it thinks that sensor is at like 100-something degrees because essentially it's seeing an open circuit. So you need to, if it's a 2009, if it's a 2011 or something, it's something totally different, and I don't know. I think that was corrected with firmware updates, but if it is a 2009, you need to get that two-prong sensor, cut the end off, strip the wire back, and twist that wire together, and then it'll work. If it is a 2009. If you have something that previously plugged into the hard drive that is now unplugged because there's nowhere for it to go, that is probably your issue. Unbelievable. So, two screws that are supposed to go for the hinge covers are in our touch. Look at this. Look at this. Who does this? What kind of repair shop does this? I know it's not the repair shop that sent this in. It's from whoever had this before them. But look at this. Like, why? Stuff is falling off my desk. That's not good. At least the bracket is there. Okay? And there's... Look at this. What did you find easiest? I just learned. I can't explain. It just happened. Okay? These screws go on our display. That's why they didn't thread into our Touch ID sensor. These aren't even remotely the right screws. Okay? Totally wrong. Bad. The right screws were in something else. So let's find the right screws, which are going to be these little stubby silver screws. There's one. There's the other. There's the other. Should be one more. There's the other. Or those might be our USB screws. Interesting. Alright, I'll just grab spares. Let me get this lined up and pushed in here so our Touch ID can go in here. Then I'll put screws in it. Get some for my screw collection here. There's one. I wish I spoke French, but I don't, unfortunately. So, I'm too tired tonight to learn French. This one's no good for that. It's fine for our center one. Then I just need one more that will thread in. I think that'll be this one. I don't need all four. There's missing ones, whatever. As long as I have two in the corners, that button should be okay. I don't like that. Yeah, it really needs four for the button feel to be adequate. Even though it's not what it's here for, I'm not here to replace missing screws, I'm still going to do it just because. There, that's perfect now. Now just one more screw for the center bracket to hold it down. A little spring mount, and we're good to go. And that is a problem solved. Okay, done. Let's get on with our board. And the fan doesn't have screws either. Lovely. Okay. Whatever. So sometimes you can see the caps if they're shorted, And I think I already see it. I think it's this one that's going to be shorted, because look at the coloration difference. See these? That one stands out as being different, okay? If I were to bet on this, I would say it's that one. Let's look at these. Any obvious cracks? Nope. I don't really want to inject voltage and do all that stuff. So I'm going to take the bet that it's that one right there, just because it looks funny. Now, we're not in the business of profiling capacitors here, but sometimes we profile capacitors. $162 ohms. Trying to find where my glass tube of NC560 went. Whatever, VS213 is fine. For lead free. Alright, I still have 161 ohms to ground, so it was not that. Now I have to inject voltage and figure out what is shorted. Fun. Okay. I'm sorry to the person in chat. My only word of advice, I guess, would be maybe seek out a forum or something in the French language, or somehow get some translation program or something to translate what I said in the video. But I don't speak French. I'm very sorry. And I wish I could help. I tried helping, but I can't. Now, we don't have to be afraid to crank up the voltage here. So, this is a 50 volt line. And I smelt something burning. What is burning? I think we may have burned our short out. It's funny how that happens. When you inject voltage and it just blows the short. But where was it? What was it? The driver? Something happened. Something blew up. Because it produced a musk of burned PCB. But what was it? I don't know. Doesn't smell like anything burnt. Oh, I know what it was. It was that. In that case, our mux is now dead. That's where a short was. Yeah, that. Knew I smelled something burning. How bad is the display side? Let's look at the display side. Yeah, the display side doesn't look bad. I mean, it looks bad, but it doesn't look terrible. So, we did burn it out, but I'm concerned for our mucks now. This is very concerning for the health and well-being of the LVDS, not LVD, EDP mucks. This is probably still fine. It's just filled with garbage. Yeah, Piranov would be able to help for sure. There's brass under there. It's just filled with corroded garbage. See that? There's brass. Almost there. Almost have it cleared. Wonder if that was our mucks that I smelled burning. It was the mucks. That's why I had no image. That's why it wasn't just no backlight. So I'm just going to replace the mucks anyway. And this is the last one. I need to finish stuff and then that's it for today. I'll probably leave here by 3. That makes sense now. That should be good. Yeah, it was the mucks. It had to have been the mucks. That makes sense because I couldn't see an image. Usually I could see an image with this problem if it's just backlight, but no, it's for sure. Let me just put 1 or 2 screws in these fans because the fans also have no screws in them for whatever nonsensical reason. Just get 2 spare screws in these. Need small ones. Where's my 00? Where did my 00 run off to? Where could my 00 be hiding? Here it is. I don't think that one. Oh, 2015. Okay, then in that case, you probably have a sensor unplugged from the screen. So if it's something unplugged from the screen, you probably have something left unplugged. Would be my guess without seeing it. Just want to get a couple screws in these fans before I forget, or else they're going to go nuts. When the fans kick on, it's going to vibrate, and yeah. There. Nope. That's good enough. Okay. So, let's change this mux real quick. The mux sits between the CPU and GPU on this board. We'll also have to put our cap back. And this one I will do ultrasonic cleaning because it does have a history of liquid damage. Probably will reassemble this tomorrow. The mux is a pretty easy chip to replace as well. Just to put that out there. Yeah, I don't even want to risk it. I'm just going to change it because I know it's going to be dead. It's this guy right here. NXP at the top, dot in the top right corner. Let's grab a donor. Stolen off donor. Heatsink not removed yet, so this one will have one. Off, off. Okay, this 1398 is done. Okay. Mux. This is our donor board. Let's get this off of here. And I like that it's got a couple of solder balls I could just leave there, so it kind of hugs the stencil. But there's a couple that I need to address here. Like this one. It's got some oxidation. Should just screw it. Okay. I need stencil now. Does this one have it? No, it does not. So I'll have to find my proper stencil for this, which is somewhere here. Probably right here. Yes. Stencil sucks. Oh, of course it moved off the chip. Of course it moved off the chip. It had to have moved off the chip, right? this bad connector out of here. Let me grab a new one. Do I have one on a donor board just chilling? Do I have new ones? I should have new ones. Used to have new ones anyway. That's sad. I'm all out of new ones. Because usually when this happens, the CPU is dead. Except on the 15 inches. But it never happens to a 15 inch. It always happens to not a 15 inch. And then after this one, it's time for me to go get some sleep. Because I'm tired. I want to go to sleep. Sleep would be really nice right now. I don't do distance learning, no. Not yet, anyway. Maybe one day I'll do distance learning. Not today. Not tonight. Tonight is time for sleeping. Is what, yeah. Anyway, let's see if this works. If this works, I'm going to end the stream. I'm going to ultrasonic this board. I'm going to finish testing that A1398. And then I'm going to go to sleep. Do have to replace that one capacitor. I have not forgotten. Alright, now I have no backlight, so I could see now I have an image, but no backlight. And that probably, let's see, is this connector not pushed all the way in? That may have something to do with that one pin that looks really nasty. Or this cable right here. Because the cable that I got wasn't necessarily the best. That one capacitor missing wouldn't do it. Well, that's booting up. I'm going to try and hunt for another display cable over here. Let's see if it gives me any image. Just backlight. So I see an apple, but no backlight. It's probably this replacement. Display connector. I'm going to replace that capacitor real fast. Just so I know it's not that. I know it's not that, but I want to make sure. And then I'll continue hunting for a connector or a cable. Might have popped the backlight fuse. As well, because we just ran voltage in there. And that could have very well popped the backlight fuse. And that explains why my current draw suddenly dropped, because the backlight fuse blew. No, not exactly, because we just went right to output. So no, that doesn't make sense. I'm just tired and not thinking, I guess. But I'll check it anyway. Yeah, I was hoping I wouldn't have to do that, Yusuf, but I know I might have to. And if the case, I'll do it tomorrow. That's fine. Okay, yeah, this connector just is a little bit, yeah, look at that. I can't trust that. That cable. So, give me a second, let me try and dig up one of those. Could have sworn we had these new, unless they're in a different spot than what I'm expecting. I don't usually handle stuff like this, so. Where could they be hiding in here? want to see that pin down in there. Don't want to mess this shield up either. See if I can just get my X-Acto knife and kind of stick it in here and see. Yeah, that pin is pretty bad in there. Okay. So that's why we have no backlight. That pin on the connector inside. Not right here. This is fine. All right here is fine. But that pin in there is not fine. I may be able to do this. Let's see. This probably won't work, but no, that pin is alright. Looks a little ugly, but it's alright. Just get a little bit of flux in here. Get my small ILS tip. Looks ugly now, but it won't when it's done. Trust me. Now I go back to the other one. I'm going to trim this back a bit. My wick, I should say, not the connector. I think that connector will be just fine. We'll see. It was worth a shot to save it. It may not work, but I wanted to at least try, because these connectors, I don't like replacing these connectors. And the pin is physically intact. But if it still has no backlight, then yeah, this connector is going to get replaced. My X-Acto, I want to straighten this shield up a bit. Just right here, pull that up, just like that, not bad. Okay. set our board back in, and we will see. I really don't want to pull the screen off. I'm not doing that tonight. I'm too tired to do that tonight. But I have a feeling it'll work. Okay. Don't be lazy. I know you're tired to do it tomorrow. Don't give it back like that. I think that'll be just fine. The pin was fine. But I still, yeah, it's hard to say. Nope, still no backlight. So I'm going to see what I have on output. But yeah, I'm probably going to replace that connector tomorrow. The pin looks intact. So I honestly... Alright, I have 55 volts on output. That's, yeah, that's that pin on that connector. It looks connected, but I think there's a little break where that pin, these connectors are. There's a pin connected to the substrate. They go up, around, then over. I think there's a break, like right at this section of it. So we'll replace that tomorrow.